This is a special report from About Space Today.
We are in a race to the moon, in a race with China to the moon. And to have a base on the moon, we need energy.
Welcome to Special Report. I'm David Denault. NASA has confirmed that they will send nuclear power stations to the moon. Here is acting NASA Administrator Sean Duffy.
So this is not a new concept. This has been discussed under Trump 1, under Biden. But we are in a race to the moon, in a race with China to the moon. And to have a base on the moon, we need energy. And some of the key locations on the moon, we're going to get solar power. But this fission technology is critically important. And so we've spent hundreds of millions of dollars studying, can we do it? We are now going to move beyond studying, and we have given direction to go, let's start to deploy our technology to move to actually make this a reality. And I think the stat we have is it's a 100 kilowatt output. That's the same amount of energy a 2,000 square foot home uses every 3.5 days. So we're not talking about massive technology. We're not launching this live. That's obviously, if you have any questions about that, no, we're not launching it live. But again, energy is important. And if we're going to be able to sustain life on the moon to then go to Mars, this technology is critically important. And I would just note that we're behind, right? If we're going to engage in the race to the moon and the race to Mars, we have to get our act together. We have to marshal all of our resources, all of our focus on going to the moon, which is what we're going to do. And again, there's a lot of things that NASA does, and a lot of people love a lot of the things that NASA does. But this is about space exploration, and this is about this next phase. A lot of people don't know even what Artemis is. Everyone knew what Apollo was. We all knew, the whole world knew what Apollo was. We were going to the moon. Artemis is we're going back. So in the first part of next year, we are going to send Artemis 2 out. Met the 4 astronauts. They're fantastic. We're going to go out around the moon and come back. Artemis 3, we are going to go back to the moon. We're going to land. The longest time we've spent in the past was 3 days. We're going to stay for 6 days. And then after that, we're able to start shipping our assets to the moon unmanned. And we'll have those assets there as our astronauts arrive and we're able to build a base. But this is critically important. There's a certain part of the moon that everyone knows is the best. We have ice there. We have sunlight there. We want to get there first and claim that for America. And to do this this part of the fission technology is critically important to sustain life, because solar won't do it, but it's just a lower amount of that fission technology that's going to allow human life to sustain.
That was acting NASA Administrator Sean Duffy. Next, Don Meyer and John Gomez will join me in the discussion. Next, as America and the world is listening to Special Report on About Space Today.
Ever dream of an island getaway at an all-inclusive resort? Or going on an island-hopping cruise to multiple island destinations? See sun-bleached beaches and swim in the azure waters of the Caribbean Sea. Call today for your special discount prices to your island getaway. This is a special offer for About Space by calling 877-747-8631. And let's go and explore the islands of the Caribbean.
Welcome back. I'm David Denault, and joining me are my co-hosts, Don Meyer and John Gomez. Well, will these power stations primarily be used at the South Pole, John?
They will, and they're gonna use a couple different things. Now, I know that the easiest thing to say is, well, it's a nuclear reactor, but it's a little bit less than that, David. What they're going to do is they're going to use, it's likely going to use a combination of solar power and then advanced systems, sort of like either nuclear fission or thermoelectric energy, to provide continuous power. Because you got to remember, they're going to be in the South Pole. It's a long night on the lunar night. So they're going to be down there doing this mission, and they're going to need to generate a lot of power to keep the landing craft moving, to keep all their parts moving. So they're going to need every little bit of energy that they can get.
Well, About Space Today first brought you a report on our Return to the Moon series, and here's part of that report.
But all we need is a little plutonium.
Oh,
I'm sure that in 1985, plutonium is available in every corner drugstore, but in 1955, it's a little hard to come by.
You might recognize those voices from Back to the Future. But did you know NASA is wrapping up the design phase of a project for a small electric generating nuclear fission reactor for use on the moon, perhaps beyond?
Nuclear fission reactors split uranium-235 atoms. When the reactor splits these atoms, it increases energy in the form of heat, which can easily be converted into electricity. This idea of nuclear power goes as far back as the 1950s, when it was starting to pop up all over the world as a safe alternative to the sort of power plants that had kept the world running for generations. In fact, a moon base would be greatly helped by nuclear power, and that's exactly why they are thinking it's the path they will take when we finally colonize the moon. NASA has been looking at a nuclear power plant that will be run by a low-enriched form of nuclear fuel. The latest estimates from NASA predict that this fission surface power system will be able to operate at around 10 kilowatts of electrical power output for the next 10 years. If that sounds impressive, it's because it is. In fact, 10 kilowatts is the equivalent to the amount of energy needed to power 5 to 8 large households. This team of scientists from Los Alamos National Laboratory, NASA, and the US Department of Energy created a new nuclear fission system that could produce the impressive 10 kilowatts of energy.
A reactor could be especially useful at the lunar South Pole, where permanently shadowed regions are thought to have trapped water ice and other volatiles. Now, these generators could pave the way for powering a sustained human presence on the lunar surface for at least 10 years. And one company has already developed a micro-reactor. Rolls-Royce has created a new classification of reactor it says that could power NASA's planned base on the moon and provide power, heat, and propulsion for future trips to Mars.
We are in a new space race. There's a lot of commercial opportunities, but also agencies having aspirations to go to the moon, stay there and beyond.
That was Rolls-Royce engineer Matthew Marriott, who says solar power generators are limited.
There's a lot of commercial opportunities, but also agencies having aspirations to go to the moon, stay there and beyond. But really, in order for everyone to do that, they need power and reliable power. There are power options in space, solar electric being a good opportunity. But there are instances where solar isn't a viable option. It can't deliver you the power that you need for space. So this product will enable all of these companies to realise their ambitions in space.
2 years ago, if you'd said to me we'd be looking at designing reactors to go on the moon, I'd have said that you were absolutely barking and it was a crazy idea.
Abby Clayton is Director for Future Programmes at Rolls-Royce.
When you think about Mars, is a really, really long way away. So it can take, up to 18 months effectively to travel to Mars using conventional types of fuels. If we kind of use the power of nuclear to do that, you can probably cut that to around a 3-month period to travel to Mars. So it actually makes that planet more accessible for us to actually go and explore, make sure that we can do experiments there. But again, also work out, can humans get to Mars? And that's certainly the plan. By 2040 is a target out there to get humans on Mars.
And before we end our report, it's important to review the problems that plagued Artemis 1 that finally launched after several attempts in November 2022. Dawn, take the lead on what's happening 3 years later.
With the Artemis 1 was delayed multiple times for weather and for other reasons. It had several hydrogen leaks that had to be redone and had to be rolled back to the VAB for a hurricane and back out to the launch pad. It was having multiple problems with loading the hydrogen so that it couldn't get it all the way loaded before it was too late because it's got a certain time limit. So it had all sorts of things that happened to it, but it finally had, because it had to have what they've heard called the red team, which I'd never heard of until they called these people the red team, that they sent people with a live rocket out to tighten down a bolt. Wow. So it was really wild, but they finally did launch on November the 16th, 2022.
When we were out there and they were talking about how the launch might have to be scrubbed again, and they deployed the red team, and those guys drove all the way out to the pad. Remember, it was like 11 or 12 drove all the way out to the pad, fixed something while the thing is on the pad getting ready, and then they drove all the way back. And I think that's when they started LOX loading after that. The Artemis 2 SLS is all new, replacing the problem that and issues, according to NASA's Jim Free during a recent news conference.
Good afternoon, everyone. Great to be here. I guess it's really great to share with you where we are with the hardware. That's where we go through all the mission objectives, look at open items and anomalies, and trying to decide if we're on the right path for Artemis 2. We looked at a number of things that have been open, the heat shield, an electronics box on the service module, and some of the release and retention bolts. Probably the highlight things. I think we have plans forward with all of those. We still have to get to root cause before we get to flight rationale. So to Bob's point about safety, that's one of the things we need to get through, because we still need to press and get our missions on a cadence where we're doing the exploration around the moon and on the surface. This is a great first step for us, but we do need to be vigilant and care about the people going on these missions.
What's not rocket science is what we all know, that we need to find H2O for life and fuel on the moon. Dawn, you have reported that NASA has identified more than a dozen sites at the lunar South Pole.
As NASA prepares to send astronauts back to the moon via the Artemis 3 mission, which will bring humans to the lunar surface, the agency has identified 13 candidate landing regions near the lunar South Pole. Each region is located within 6 degrees latitude of the lunar South Pole and contain diverse geologic features. Mark Kersich, Deputy Associate Administrator for the Artemis Campaign Development Division at NASA headquarters in Washington, said, "Selecting these regions means we are one giant leap closer to returning humans to the moon for the first time since Apollo. When we do, it will be unlike any mission that's come before, as astronauts venture into dark areas previously unexplored by humans and lay the groundwork for future long-term stays." Here are NASA astronaut Jessica Watkins, planetary geologist Kelsey Young, former curator of ices and organics at the Johnson Space Center, Julie Mitchell, and lunar geologist Natalie Curran to explain the importance of exploring the lunar South Pole.
Imagine if you were an alien who, was visiting the Earth for the first time from some other galaxy. Imagine only visiting the United States and never visiting any other part of the Earth's surface. That's essentially what we've done with the Apollo missions. Really been able to do wonderful and groundbreaking science with the samples collected during the Apollo missions. But again, we visited only a very small part of the lunar surface.
The way that I think about it is it's the equivalent of landing on Earth and getting rocks from Kansas. It would give us insight into one particular location on the Earth, but not at all the diversity of what we see on the Earth, what we know is present on the Earth. So the ability to go to a different site, a different location, get different samples will just enrich what we have already learned from our Apollo samples.
There's a lot left to be learned about the moon, and it starts with the South Pole.
Artemis astronauts will fulfill a different mission in a unique environment. The moon's South Pole region has resources that are vital for long-term exploration. Because the moon is barely tilted relative to the sun hovers over the horizon at the South Pole. Imagine a flashlight turned on, laying on a table. That's how the sun illuminates the South Pole.
From an exploration perspective, if we can understand just how much water there is and where it is and how to get it out of the regolith of the moon, we can turn it into really important things like drinking water for astronauts and even rocket fuel to take them back home. So really understanding these resources and how to use them is one of the objectives of the Artemis program, and it's what makes the South Pole of the moon so exciting.
For future missions using the Starship, Elon Musk wants to refuel in space. Well, how will that work, and what are the advantages and disadvantages? John, want to start us?
Sure. Well, a couple of things to keep in mind here. That one, they're still doing test flights, and one of the test flights will involve a simulated fuel transfer. Now, the way this works is actually a second rocket will go up, and what the long-term plan here is SpaceX will have what they consider to be dedicated tankers. So they'll fill them up with fuel, launch them into orbit, and they'll wait in orbit for Starship. Starship will align, they'll connect, fuel up Starship, off Starship goes. The tanker can either fall back to Earth and be reused, or can stay there depending on how much fuel is in the tank as needed. We're talking long-term, like 6-month duration to Mars type things where we're really going to see this. And don't be surprised if in the future, as we get into the 2030s and maybe even the 2040s, that SpaceX will be launching different styles of tankers and having them pushed out into different points between Earth and Mars, so that way they can act as a way station for Starship as it flies to Mars. Hopefully at the end of this decade and early next decade. But it's not without its complications. It's not without its concerns. But boy, does the future look bright with Starship and refueling.
Don, this is something new for you, being in the space shuttle program for some 28 years of refueling in space. So what are your thoughts about the advantages and maybe dangers?
Of course, all space travel is dangerous, but the advantages to having these refueling in space is that you don't have to carry as much fuel aboard the rocket, so you can have more life support, you can have more things for people to do, have more space for them, because stir crazy over a 6-month period. So I think it's a really interesting idea. I hope that they can pull it off, and I look forward to watching it happen.
And what we haven't discussed is human hibernation for traveling months or years in space. But that's another story. And if you like our series, click like, follow, and hit the subscribe button. Thank you for taking time to listen from your home or from where you work. For Don Meyer, John Gomez, I'm David Denault.
This has been a special report from About Space Today.